Hello. Today in this class, we are talking a lot about ellipse. First, we will discuss a few concepts about the ellipse, and then we will go to the multiple choice questions also. So, first of all, you can say ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0 can be the equation of ellipse if delta, what is delta? ABC plus 2FGH minus AF square minus BG square minus CH square is not 0 and H square is less than AB. So this is the main condition. And after that, how to form an ellipse? I will take a few set of points. But when I'm taking these few set of points, what I will be seeing is there is a fixed point. Let this fixed point be S. It is called focus of the ellipse. And let there be a line L. This is fixed line and it is called directrix of the ellipse. Now, why did I take fixed point and fixed line? When I take any of these points, find the distance between S and P, that is SP, and find the distance between P and the directrix, that is perpendicular distance PM. And if I take the ratio, if I get E always, not only this point P1, I can take point P2 and then take the ratio of SP2 and P2M2. So this is for P1. SP2 by P2M2 will be also equal to E. Similarly, I can take one more point P3. I can take the ratio of SP3 by P3M3. Then also I will get E. And here E will be less than 1. The E which I am getting will be less than 1. If such condition is satisfied, then the line joining all such points P1, P2, P3, if you join all these points, then the diagram you get is that of ellipse. So this is the definition of ellipse. Now, the ellipse has a standard equation. So the standard equation of ellipse is x square by a square plus y square by b square equal to 1. Remember here a has to be greater than b. Now, how such ellipse look like? This a if you take and multiply by 2, that will be the length of major axis of the ellipse. And if you take b and multiply by 2, that would be the length of minor axis of the ellipse. So major axis we will take A dash, minor axis we will take B dash. So I'm drawing here major axis A dash and I will draw minor axis B dash. In this, let C 0, 0 be the center of the ellipse. I have to write here center. So let me take center of the ellipse as 0, 0. Now there are two foci on the ellipse. One is S dash and the other is S. S and S dash are called foci of the ellipse. The foci are given as AE, 0 and minus AE, 0. So this S is AE, 0 and S dash is minus AE, 0. What is E? E is called eccentricity of the ellipse. E's value will be less than 1. Not only that, to get the value of E, there is a relation. You can write B square equal to A square into 1 minus E square. This is the relation between A, B and E. Now, A and A dash are called vertices of the ellipse. The next point is vertices are A, that is A, 0 and A dash, that is minus A, 0. So A is A, 0, A dash is minus A, 0. Similarly, B is 0, B and B dash is 0, negative B. So for B, I can write 0, B and B dash 0, negative B. That is minus B. So if I draw the ellipse here, this is the ellipse which I get. This is how I will get the ellipse. This ellipse has two directrices, here one and here the other one. L and L dash are the directrices. So equation of directrices of the ellipse are x equal to A by E and x equal to minus A by E. Equation of this directrix is x equal to A by E. Equation of this directrix is x equal to minus A by E. Then there is a chord of the ellipse passing through the focus of the ellipse and perpendicular to the major axis of the ellipse. So this chord is nothing but LL dash and it is called lattice rectum of the ellipse. So equation of lattice recta, there are two lattice rectums. One is x equal to plus AE, the other one is x equal to minus AE. And the length of lattice rectum of ellipse is given as 2b square by A. So these all you have to remember. Not only that, a few more relations you can see in ellipse. Suppose if I take a point P here, join S with P and join S dash with P. I'm going to write here because of lack of space. Then I can say that PS plus PS dash will be always equal to 2A. That is the length of the major axis. And next, one more point is, suppose if there is a chord which is passing through center of the conic. This is the chord passing through the center of the conic. This center will be the midpoint of the chord. Always any chord which passes through the center of the ellipse, for that center will be the midpoint. Similarly, this center O, it's not only midpoint of the conic, the center O will be midpoint of SS dash. The center O will be midpoint of AA dash. The center O will be midpoint of BB dash. For all, many of them, S is the center. Then I have already drawn SP. You can see here, this is SP. This is SP dash. SP and SP dash are called focal distances of P. To measure SP, the measure of SP will be A minus EX1 and measure of SP dash will be, or S dash P. Better we will write it as S dash P. The measure of S dash P will be A plus EX1. So these all you have to learn about the ellipse and understand. Now, there is another form of ellipse. The other form of ellipse is different from what I have written on the previous page. The other form of the ellipse is x square by a square plus y square by b square equal to 1. You may say that it is the same form, but what I want to say here is a will be less than b. That means the major axis will be BB dash and its length will be 2b. Minor axis will be AA dash and its length would be 2a. So if I draw the ellipse, it will look like this. This is the major axis of the ellipse, BB dash, and this is the minor axis of the ellipse, AA dash. So the ellipse formed will look like this. This is the diagram I can see. Now, center of this ellipse will be 0, 0. So I will write center is 0, 0. This ellipse also has two foci, S and S dash, but the focus will be 0, BE and 0, minus BE. The two foci of the ellipse are 0, BE and 0, minus BE. Then the vertices of the ellipse B and B dash are 0, B, 0, minus B. So vertices of the ellipse you can take B 0, B and B dash 0, minus B. Then the ellipse has two directrices, one here and one the other way. This is a directrix. This is also directrix. The equation of directrices are y equal to plus b by e, y equal to minus b by e. Then here, one more thing I want to add in the previous one as well as this one. The minor axis of the ellipse is x-axis. The major axis of the ellipse is y-axis. In the same way, in previous page also, the major axis of the ellipse is x-axis and the minor axis of the ellipse is y-axis. So that also we will write here. Major axis equation is x-axis equation is y equal to 0. Minor axis, that is y-axis equation is x equal to 0. Same thing we can write here also. The major axis of the ellipse is x-axis is not the major axis here. X-axis is the minor axis. So major axis is y-axis and that is x equal to 0. Minor axis is x-axis, that is y equal to 0. This also we can write. Then some more things we can add. The length of the lattice rectum. Lattice rectum means I have to draw. I'll take a different color. Lattice rectum is a chord LL dash. Lattice rectum is a chord LL dash passing through focus and perpendicular to major axis. So length of lattice rectum in this case of ellipse will be 2a square by b. And equations of lattice recta are x equal to plus or minus be. Instead of x, we have to write y here. Y equal to plus or minus be are the equations of lattice recta. In this type of ellipse, eccentricity, to find eccentricity, I will write eccentricity. The formula we will use is a square equal to b square into 1 minus e square. So this is all about this kind of ellipse. Apart from this, there are some other special form of ellipse which we can take into account. That special form is x minus h whole square by a square plus y minus k whole square by b square equal to 1. So, for such ellipse, the center will be h comma k. The remaining properties all will be same. Here a is greater than b, so the properties, all other terms will be same as what we have taken. But here the ellipse is actually in the form x square by a square plus y square by b square equal to 1, where big X is nothing but x minus h, big Y is nothing but y minus k. Now suppose, so I told you x square by a square plus y square by b square equal to 1. This is the ellipse. This is the ellipse. This is A, this is B. Now in this ellipse, if A and B are equal, that means like this. This is A, this is B. Then you will not get an ellipse exactly. You will get a circle when A and B are equal. Then what happens is x square by a square plus y square by, in place of b square, I will write a square equal to 1, or I will have x square plus y square equal to a square. That is the equation of the circle. The circle's equation you will get. It is also one form of ellipse only. Okay. This circle, it is actually called not normal circle, it is called auxiliary circle. Okay, now we will learn something more about tangents and normals to ellipse. The equation of the ellipse is written as S, that is x square by a square plus y square by b square minus 1 equal to 0. Suppose if there is an ellipse like this, on the ellipse there is a point x1, y1, and at this point x1, y1, if a tangent is drawn to the ellipse, then I can write equation of tangent as x1 by a square plus y1 by b square equal to 1. But for an ellipse, we have parametric equations also. Parametric equations of ellipse. What are they? Let me write ellipse neatly. What are the parametric equations of ellipse? There should be a point which can be called as theta. So x will be equal to a cos theta, y will be equal to b sin theta. So these are represent the parametric equations. So any point theta can be written as a cos theta, comma b sin theta. Suppose if P is a point theta, then P I will write a cos theta, comma b sin theta. At this point, if a tangent is drawn and it is drawn to the ellipse, this tangent is nothing but tangent of the ellipse. Which ellipse I'm talking about? X square by a square plus y square by b square equal to 1. Then the parametric equation of tangent can be written. Parametric equation of tangent. We have a different formula for this. So the parametric equation of tangent is x cos theta by a plus y sin theta by b equal to 1. So sometimes in the problems you will be using this also. Okay, suppose there is an ellipse x square by a square plus y square by b square equal to 1. There is a point P here, theta 1, and there is a point Q here, theta 2. Now suppose at these 2 points I am drawing tangent. At P, I am drawing a tangent. At Q, I am drawing a tangent. We can find the angle alpha between the tangents. We can find the angle alpha between the tangents. In the same way, you can also find point of intersection R. To find point of intersection R, the formula is a cos theta 1 plus theta 2 by 2 by cos theta 1 minus theta 2 by 2, comma, b sine theta 1 plus theta 2 by 2 by cos theta 1 minus theta 2 by 2. This is called point of intersection of the two tangents. Next is, I can say y equal to mx plus c is tangent to the ellipse x square by a square plus y square by b square equal to 1. So if I can say if c square equal to a square m square plus b square, this is called condition of tangency. And then the equation of the tangent becomes y equal to mx plus or minus root of a square m square plus b square. Because in place of c, we can write this. That will be the equation of the tangent. Now, if this is the ellipse, and on the ellipse I am taking x1, y1, and at x1, y1, I am drawing tangent to the ellipse. This is the tangent. But if I draw a line passing through the same point and perpendicular to the tangent, that is called normal of the ellipse. So a line which is passing through x1, y1 and which is perpendicular to the tangent is called normal of the ellipse. The equation of normal at x1, y1 can be given as x minus x1 by x1 square by a square equal to y minus y1 by y1 square by b square. This is how I get the equation of normal. Now, at a point theta also we can find parametric equation of normal. And the parametric equation is ax secant theta minus by cosecant theta equal to a square minus b square. Not only that, some more. Suppose this is the ellipse. Here there is a point theta 1 and here there is a point theta 2. Okay, so now you are drawing a tangent at p theta 1, you are drawing a tangent at p theta 2. There are two tangents drawn at these 2 points. Now, this I will name it as Q. So this is point of contact of the tangent. This is another point of contact of the tangent. I have to write this is another point of contact. Yeah, this is another point of contact. If I join these 2 points of contacts, the chord which I get will be called as chord of contact. Is that clear? So PQ is called chord of contact, and the equation of PQ is given as x by a cos theta 1 plus theta 2 by 2 plus y by b sin theta 1 plus theta 2 by 2 equal to cos of theta 1 minus theta 2 by 2. This is the equation of chord of contact. Similarly, suppose this is the ellipse and suppose there is a chord PQ. This is midpoint of the chord PQ. So we will take x1, y1 as the midpoint of the chord PQ. Then I can write equation of chord as S1 equal to S11. Now what is S1? S1 can be called as I told you, what can be taken as equation of ellipse. So equation of the ellipse can be sometimes written as S. So with that you can get S1 and S11. Suppose if S I will take x square by a square plus y square by b square minus 1 equal to 0. S1 will be x1 by a square plus y1 by b square minus 1. In the same way, S11 will be x1 square by a square plus y1 square by b square. So when I say equation of the chord whose midpoint is x1, y1 is S1 equal to S11, I mean x1 by a square plus y1 by b square equal to x1 square by a square plus y1 square by b square. This is the equation of the chord. Next, suppose this is the ellipse. There is a point P x1 y1 here. The ellipse is x square by a square plus y square by b square equal to 1. Now, suppose from P you are drawing a pair of tangents to the ellipse, PT1 and PT2. Then you can write equation of this pair of tangents as SS1 equal to T square. What is S? X square by a square plus y square by b square minus 1. What is S1? X1, 1 minute. So S1 is here in this context, I have to write either S11, or if I write S1, I have to change the form. So I will write SS11. That is x1 square by a square plus y1 square by b square minus 1 equal to this t is nothing but S1. Instead of t, I can write S1, S1 square. So SS1 equal to S1 square also I can write. SS11 equal to S1 square. This form I can write, or I can write this form. Anything. because you have learned this in parabola, so I try to write this. Otherwise you can write in this way: x(x1) by a square plus y(y1) by b square minus 1 whole square. So this is equation of pair of tangents. Then next, already in one of the pages I told you chord of contact. Suppose here the point is x1 y1 from where you are drawing point R. The point R is x1 y1 from where you are drawing a pair of tangents. Then in such case, equation of chord of contact can be written in another way. That is x(x1) by a square plus y(y1) by b square equal to 1. Next, now in this chapter you will learn something new called pole and polar. Suppose x1 y1 is a point. Polar of this point with respect to the ellipse x square by a square plus y square by b square equal to 1 is, equation of polar is x(x1) by a square plus y(y1) by b square equal to 1. And this point x1 y1 is called pole. This equation is equation of polar. So these are the few topics, few new terms which you will be learning in this chapter, ellipse. After this, we can go to some multiple choice questions related to this chapter, related to the points you have learned. The first question is, you have to find eccentricity of the ellipse whose equation is 9x square plus 5y square minus 30y equal to 0. So first of all, what I will do is, I will write this equation as 9x square plus 5y square minus 30y equal to 0. Next, I will write 9x square plus 5, I will take common, y square minus 6y equal to 0. 9x square plus 5 times, because this is the number 6, if you take half of 6 and if you square it, that means it is 3 square. So what I have to do is, I have to add 3 square and subtract 3 square. Why am I doing is, I'm modifying the equation of the ellipse first. 9x square plus 5 into, when you take all these as a pair, it is y minus 3 whole square minus 5 into 9 is 45. So 9x square plus 5 into y minus 3 whole square equal to 45. I can divide by 45 everywhere. What is the purpose of dividing by 45 everywhere? I will get the equation of the ellipse. X square by 5 plus y minus 3 whole square by 9 equal to 1. This is the standard form of the ellipse which I got here. It is looking like x square by a square plus y square by b square equal to 1, where x is x minus h. x minus 0. Y is y minus 3. Okay, in such case, I can take a square as 5 and b square as 9. So I'll continue. Because a square is 5 and b square is 9, you can see a is less than b. So this is the second type of ellipse. Because what is the question saying? It is asking to find eccentricity. So the formula I will be taking is a square equal to b square into 1 minus e square. This formula. So a square is 5, b square is 9, 1 minus e square we don't know. So 5 by 9 equal to 1 minus e square equal to 1 minus 5 by 9. Or that is equal to 4 by 9. That means E will be 2 by 3. So you can go to the option 2 by 3. Let's go to the second question. The foci of the ellipse 25 into x plus 1 whole square plus 9 into y plus 2 whole square equal to 225. So we have to find foci. Before that, I will change the form of the ellipse. 25 into x plus 1 whole square plus 9 into y plus 2 whole square equal to 225. So everywhere I will divide by 25. So that I will get x plus 1 whole square plus 9 by 25 into y plus 2 whole square. Or I can change this form. What I will do is I will divide by 225 everywhere. Instead of 25, I will divide by 225. So x plus 1 whole square will have denominator 9. Y plus 2 whole square has denominator 25 equal to 1. Because this is looking like standard form of ellipse. X square by a square plus y square by b square equal to 1. I can write x is x plus 1 and y is y plus 2. And at the same time, I can write a square is 9, b square is 25 and a is less than b. So because we have to find the foci and a is less than b, the foci are 0, b, be and 0, minus be. So 0, b times e. What is e? I don't know e. So I have to find e. To find e, what is the formula you have learned? A square equal to b square into 1 minus e square. A square is 9, b square is 25, 1 minus e square. So e square will be 1 minus 9 by 25. Am I clear? Okay, so that means 1 minus 9 by 25 means 16 by 25. So E is 4 by 5. So B into E, 5 into 4 by 5 and 0 minus B into E. So you can cancel 5 and 5 and then you can find the equation of ellipse, but they are just asking you foci. 0 comma 4, 0 comma negative 4. But there is a problem here. I can take 0 comma 4, 0 comma negative 4, but what is happening here, you see. I will do this on the next page. I said foci is 0 comma BE and 0 comma minus BE. But this is the ellipse x square by a square plus y square by b square equal to 1, where x is x plus 1 and y is y plus 2. So here you can see the y coordinate is BE, the y coordinate is negative BE. Isn't it? So I can write y is y plus 2 equal to BE. Here also y plus 2 equal to minus BE. Or y coordinate will be BE minus 2, y coordinate will be minus BE minus 2. So what is B? In the previous page, what is B and what is E? B is 5, E is 4 by 5. So B is 5, E is 4 by 5 minus 2. B is 5, E is 4 by 5 minus 2. So here I will have 2 and here after cancelling I have minus 6. So the y coordinate of the foci, how can I write? Y coordinate I can write 2 and the other y coordinate I can write minus 6. Isn't it? So x coordinate will be x plus 1. So what is the x coordinate I have? 0 at present. So x coordinate will be minus 1. That means here I can write minus 1. Here I can write minus 1. So in this way I will find the foci of the ellipse. So there are many things you have to learn here about transformations. Directly you can't take the answer. So based on this, we will go to the next question. That is third question. You have to find lattice rectum of the ellipse 3x square plus 4y square minus 6x plus 8y minus 5 equal to 0. First of all, the ellipse is not in proper form. I'll take 3x square minus 6x, pair them. I will take 4y square plus 8y, pair them. Then minus 5 equal to 0. Take 3 common, x square minus 2x. Take 4 common, y square plus 2y minus 5 equal to 0. Now, because I have 2, so I will take 2, divide by 2 and square it. So it is 1 square. That means I will add 1 square and subtract 1 square. 4 into, again I have y square plus 2y. So I will add 1 square, I will subtract 1 square minus 5 equal to 0. So I can write this entire thing as x minus 1 whole square minus 3. And here this entire thing as y plus 1 whole square minus 4 minus 5 equal to 0. 3 into x minus 1 whole square plus 4 into y plus 1 whole square minus 3, minus 4, minus 7, and then minus 5. That is minus 12 can be written as 12. Now everywhere divide by 12. So that you will have x minus 1 whole square by 4 plus y plus 1 whole square by 3 equal to 1. Clearly, A is greater than B here in this kind of ellipse. So this kind of ellipse I can write x square by 4 plus y square by 3 equal to 1. But remember, x is x minus 1 and y is y plus 1. Then a square is 4, b square is 3. Because a is greater than b, you can find, because they are asking you lattice rectum of the ellipse. The length of lattice rectum of the ellipse will be 2b square by a. That means 2 into 3 by 2, because a is 2. Or the length of lattice rectum is 3, which you have in the option. Yes, now let's go to question number 4. If length of lattice rectum of an ellipse is 5 by 2 and eccentricity is 1 by 2, then equation of ellipse is. So, first of all, we will take, let equation of the ellipse be x square by a square plus y square by b square equal to 1. Now, what is the length of lattice rectum for an ellipse? It is 2b square by a and it is given by 5 by 2. Now, what can I write for b square? What's the formula for b square for ellipse? B square I can write a square into 1 minus e square and down by a equal to 5 by 2. So 1a will cancel. What am I doing here? I know 2a into 1 minus e square, because eccentricity is given as 1 by 2, e square will be 1 by 4 equal to 5 by 2. So 2a into 3 by 4 equal to 5 by 2. 2 2's it will cancel, both the 2's will cancel. So what do you have here? You have 3a equal to 5, or from this you will get a as 5 by 3. Once you get a as 5 by 3, we know that we have taken 2b square by a is equal to 5 by 2, length of lattice rectum. So I will write a as 5 by 3 equal to 5 by 2. So 2b square is 25 by 6, or b square equal to 25 by 12. So if b square is 25 by 12 and a square is 25 by 9, you can write equation of ellipse. What is equation of the ellipse? x square by a square plus y square by b square equal to 1. This is the equation of the ellipse which they are asking for in the question. Next is example 5. If the distance between foci is 2 and distance between directrices is 5, then equation of ellipse you have to find. So distance between foci, what is the distance between foci actually? It is nothing but 2 times AE, which is 5. Similarly, distance between directrices, that is 2A by E, is 5. Distance between foci is 2. Sorry. Distance between foci is 2. Distance between directrices is 5. That means AE is 1. That means A by E is 5 by 2. So from this, you can write E as 1 by A. So E I will write 1 by A. Or I can write A square equal to 5 by 2. If A square is 5 by 2, I can find what is E. Because AE equal to 1, A square, E square will be 1. A square is 5 by 2. E square is 1. So E square will be 2 by 5. Or E will be root of T by 2 by 5. E I can take as root of 2 by 5. Isn't it? Will I get E as 2 by 5? Okay. So once I get E as 2 by root of 2 by 5, I can find B also. What is the formula to find B? B square equal to A square into 1 minus E square. What did I get for A square? 5 by 2 into 1 minus, what did I get for E square? 2 by 5. So 5 by 2 into 3 by 5. 5 and 5 will cancel. B square is 3 by 2. So what will be the equation of ellipse? X square by A square plus Y square by B square equal to 1. Or I can write 2x square by 5 plus 2y square by 3 equal to 1. Or I can take common denominator 15. I can take common denominator 15. And then I can write 6x square plus 10y square equal to 1. Or 6x square plus 10y square equal to 15. That's the equation of the ellipse. So whatever conditions are given to you, using that, if you know the formulas well, you can get the equation of ellipse. Let's go to question number 6. If foci are 2 comma 0 and minus 2 comma 0, one more information they gave you. One second, I will write neatly. What is the second information they have given you? Lattice rectum. Lattice rectum. What is the formula for lattice rectum? 2b square by a. It is given as 6. Then you have to find equation of ellipse. First of all, foci means AE comma 0 minus AE comma 0. So if I write AE equal to 2, that will be right, isn't it? AE will be equal to 2. Minus AE is minus 2. And now 2 b square I will write a square into 1 minus e square by a equal to 6. 1a I will cancel. Now using this, I will find A or I will find E. Anything I can find for these two. So how will I find? 2A minus 2AE square equal to 6. What I can write for E? I can write 2 by A. 2A minus 2A into E square is 4 by A square equal to 6. So 1A will cancel. 2A minus 8 by A equal to 6. Or taking A common, 2A square minus 8 equal to 6. Or with the help of this, I can get an equation. What is that equation? 2A square minus 8 equal to 6A. 2A square minus 8 equal to 6A. 2A square minus 6A minus 8 equal to 0. Or A square minus 3A minus 4 equal to 0. I can factorize as A minus 4 into A plus 1 equal to 0. So A is either minus 1 or A is 4. Two values of A I will get. Now, when A is minus 1, what can I do? A is 2, right? So, because A is 2, A is minus 1, E equal to 2, E will be minus 2. Suppose if A is equal to 4, because as A is equal to 2 and A is 4, so 4E equal to 2 or E equal to 1 by 2. There are two values of E I got. Now with the help of this A's and E's, I can find B square, A square into 1 minus E square. What is A square? Which one I will take? Which case I will take? E has to be less than 1 because we are talking about ellipse. E has to be less than 1 and E has to be greater than 0. So I will not take this case. I will take A equal to 4, E equal to 1 by 2. I will take A equal to 4 and E equal to 1 by 2. So 16 into 1 minus 1 by 4. that is 16 into 3 by 4, or b square is 12, a square is 16. That means I can write equation of ellipse as x square by 16 plus y square by 12, x square by 16 plus y square by 12 equal to 1. This is the equation of the ellipse from the given information. I think we can do one more last problem. Seventh one. In a model, it is shown that an arc of a bridge is semi-elliptical with horizontal major axis. So this is the major axis. This is semi-elliptical bridge which they are talking about. If length of base is 9 meters, that means this length of base will be 9 meters. That is given. And highest part of the bridge is 3 meters from the horizontal. So from horizontal, the maximum height of the bridge is 3 meters. Let me write it here. This is the maximum height of the bridge. This is 3 meters. It is given from the horizontal. So you have to find best approximation of height of arc 2 meters from center of base. So what they're asking in the question is 2 meters away from the center of the base, 2 meters away. You are measuring the height of the arc H. This is what you have to find. So for that, I will think this is x-axis. This is y-axis. This is origin. So the major axis 2A, I will take 9. The minor axis 2B, I will take 6. That means A is 9 by 2 and B is 3. So I can write equation of ellipse as x square by 81 by 4 plus y square by 9 equal to 1, or 4x square by 81 plus y square by 9, that is equal to 1. Now, if I take this point, x coordinate is 2, y coordinate I don't know. So because 2 comma y is on the ellipse, I can put 2 comma y on this ellipse. So when I put 2, I will have 16 by 81 plus y square by 9 equal to 1. Or y square by 9 equal to 1 minus 16 by 81. Y square equal to 9 times 81 minus 16 by 81. So y square I can write 9 nines here. 81 minus 16 is 65 by 9. So y will be root 65 by 3. So the height which they are asking for is root 65 by 3, or approximately root 64 by 3, or approximately 8 by 3. So I think we have done sufficient questions for today. With this, we have completed ellipse chapter. The next chapter we are going to learn in the next class is about hyperbola. Learn the concepts of hyperbola, learn ellipse also, be practicing more and more problems. See you for the next class.